Welcome to ClickMyProject.com. Now we are going to discuss about brain tumor detection based on machine learning algorithms. Abstract: automated defect detection in medical imaging has become the emergent field in several medical diagnostic applications. Automated detection of tumor in magnetic resonance imaging is very crucial as it provides the information about abnormal tissue which is necessary for planning the treatment. The conventional method for defect detection in magnetic resonance brain image is human inspection. This method is impractical for large amount of data, so automated tumor detection methods are developed as it would save the radiologist time. The MRI brain tumor detection is a complicated task due to the complexity and variance of tumors. In this paper, tumor is detected in brain MRI using the machine learning algorithms. The proposed work is divided into three parts. Pre-processing steps are applied on the brain MRI images. Texture features are extracted using the Gray Level Co-occurrence Matrix, that is GLCM, and then classification is done by using machine learning and fuzzy C-means algorithm. This is our project flow diagram. We have 6 modules in our process. First, our process is going to start with data selection and loading. Here we are going to select our data based upon the brain MRI images, and then data pre-processing. Data pre-processing means cleaning the data set, and then data splitting. We are going to split our data into training set and the testing set. Training set is for model creation, and then testing set is for prediction purpose. Then feature extraction. Here we are going to select our best features among our data with the use of GLCM method, and then classification, that is algorithm implementation. We have used two algorithms. One is fuzzy C-means clustering and another one is a logistic regression. At last, performance analysis and report generation. Here we are going to check our algorithm performances and then prediction. Now we are going to see our project output. Our first module is data selection and loading. This is our input data. In our data set we have two categories. One is yes and another one is no. Yes means tumor, no means normal condition. First we are going to check minimum height and maximum height, minimum width and maximum width for S category, and then minimum height and maximum height, minimum width and maximum width for no category. And then data pre-processing. Data pre-processing means cleaning our data set. Here we have images as our data, so we are going to resize the image into the same height and the same width, and then we are going to do binarization. After that we are going to convert our images into the array by using the numpy. These are pre-processed data. And then data splitting. Data splitting means we are going to split our data into training set and a testing set. Training set is to train our model, testing set is for prediction purpose. And then feature extraction. Feature extraction means reducing our features. If we give more number of input as a data, system will take time to train a model, so that we are going to select best features among our input by using the Gray Level Co-occurrence Matrix, that is a GLCM method. And then fourth module is algorithm implementation. We have used two algorithms. One is a fuzzy C means clustering and another one is a logistic regression. Fuzzy C means is a data clustering technique in which a data is set into group, and then we are going to find the result based upon the centroid points. Final centroid points, here is the result for final centroid point with our input data, and then here is the result for fuzzy C means clustering algorithm. And then logistic regression. Logistic regression is a machine learning algorithm which comes under the supervised learning technique. It is used to predict the categorical dependent variable using the given set of independent variable. Logistic regression predicts the output of a categorical dependent variable. Therefore, output must be in the categorical or discrete value, that is zeros and ones. This is the accuracy of a logistic regression algorithm, and then this is the prediction for of our input data, which is predicted as no, that is a normal condition. And then this is the confusion matrix, that is a true positive, true negative, false positive, false negative. True positive means total number of correct prediction with a correct result, and then true negative means correct prediction with a negative result, and then false positive means our prediction is false, but our result is positive, and then false negative means both the result and both the prediction is wrong. And at last, this is the input image which is predicted as no category.